Consider question 36. It reads, when an empty freight train of mass m0 starts, loading of coal in the train begins at a constant rate r from a stationary hopper. If the track is horizontal and engine pull F is a constant, deduce expression for speed of the train as a function of time. Neglect all resistive forces. So let's consider this is your train, and there is a hopper which is pouring or loading this coal on it. This is the situation when at the time t, when the speed was v, and the total mass of the system excluding the hopper is m, and force is acting as F. You wait for delta t time, so next time is going to be t plus delta t. At that moment, the system without the hopper will have a mass m plus delta m, and the speed will go by v from v to v plus delta v. The force is constant F that is acting. Okay, so for this time duration, we can think of that impulse momentum equation will be equal to force into the time must be equal to the change in momentum, final momentum minus initial momentum. In our system, this hopper has been excluded. So you'll find this right hand side is going to be like m plus delta m into v plus delta v, that's final momentum, minus m into v initial momentum. Now when you expand it, you'll find there's going to be four terms. One term is going to be mv, another is going to be delta mv, another going to be m delta v, and the last is going to be delta m delta v, and there is a minus mv as well. So this mv and this mv will get cancelled out, and you'll find this is delta mv and then plus m delta v, and there's a delta m delta v. Now this delta change is very small change, right? So if you multiply the two small numbers like delta m delta v, this will be very small as compared to these terms. So this delta m delta v can be dropped. So you'll get it like f delta t is equal to delta mv plus m delta v. So this is going to be the equation that will govern the motion of this train. Then you will find we can divide by delta t both sides. So delta can be replaced as a d. So it's like f is equal to dm by dt into v plus m dv by dt. Now question says that dm by dt, that's the rate at which the mass is being changed, is r. And after t time, how much the mass of the system will become? Initially empty mass was m0 plus the mass of the coal that went in. Now if it is falling at a rate r for t time, rate is a constant, so rt will be the extra mass that is going to come in, so total mass will become m0 plus rt. Now put that m value over here, the dm by dt value is over there. So you'll find f is equal to r into v plus m, could be written as m0 plus rt into dv by dt. Now here r is a constant, t is a variable, v is a variable, f is a constant, m0 is a constant. Now from here we can find v as a function of time. So that's a differential equation. So we can write a dv. Now separation of variable, bring this rv this side, so that becomes f minus rv, and bring it downside, so that will become dv divided by f minus rv. And right hand side we can take it like dt divided by m0 plus rt. And then I have integrated both sides from initial velocity 0 to any velocity v for initial time 0 to any time t. You'll find this is going to be having integration as ln f minus rv divided by minus r, that is coefficient of v, and having limits from 0 to v. So I have placed the limit quickly. So this will be using ln m minus ln n formula, so that they will be divided. Similarly, right hand side will have 1 upon r ln m0 plus rt, and then limit will be running from 0 to t, so that will have this thing. You can check this calculation. R will get cancelled out, this minus can be absorbed by reversing or inverting this. So it will be ln f divided by f minus rv is equal to ln m0 plus rt divided by m0. ln can be cancelled, or you can say these arguments have to be identical. That means f divided by f minus rv must be equal to m0 plus rt divided by m0. And then you can do calculations to find v. So what I did is this, I multiplied this m0 across, so that it become m0 f divided by this m0 plus rt. So this is f minus rv, because this is the only term that has a v. So from here v could be rv could be written as f minus this term, which will lead to f rt divided by m0 plus rt. So r can be cancelled, so v turn out to be ft divided by m0 plus rt. So you can fill the baby steps of the calculations. Idea is quite simple. We started with impulse equation, we created it, and we dropped the smaller term, integrated, got to this number, and that is our final response. Hence, we will say this is the correct response. Thank you.